It was the spring of 1943, when German confidence in engineering supremacy was still unshaken, and the Wehrmacht believed that no foreign machine could rival the precision of German craftsmanship. But deep inside the test grounds of Count Kummersdorf, south of Berlin, that illusion was about to crack. Under the grey skies of Brandenburg, a train arrived carrying an unfamiliar silhouette, its shape squat, its turret rounded, its hull broad and thick. Painted hastily over the olive-drab American markings were black crosses. On the manifest, the name was simple: Panzerkampfwagen M4 748A, the captured American Sherman. The tank had been seized in North Africa, near Tunisia. It was intact, almost miraculously so, and shipped across the Mediterranean for study. Few of the German engineers expected to be impressed. To them, the Americans were industrialists, not craftsmen. They built tractors, not tanks. What could mass production possibly teach those who had perfected the Panther and the Tiger? But when the Sherman's engine came to life for the first time under German supervision, the test officers began to exchange puzzled glances. It did not choke, it did not cough, it did not leak oil. It simply started and kept running. At the Kummersdorf proving ground, the Germans treated every captured vehicle the same way. Weigh it, measure its armor angles, calculate its resistance, and drive it until something broke. The Sherman, however, refused to oblige. Its intercontinental R975 radial engine hummed with a steadiness that baffled the mechanics. Its transmission, though simpler than the complex German gearboxes, shifted smoothly. Its suspension, based on the easy-to-maintain vertical vollet spring system, took the punishment of rough terrain without shedding parts. For the engineers who had spent months trying to keep the Panther's intricate final drives from failing, this was something close to heresy. They took apart the Sherman's powertrain, expecting to find crude shortcuts or poor machining. Instead, they found consistency. The welds were clean, the tolerances practical, the assembly intuitive. Every major component could be removed by field crews with minimal tools. It was not built to impress. It was built to survive. Inside the hangar, the lead engineer from the Heereswaffenamt, notebook in hand, muttered words that would later echo through post-war reports. "It is. Simple, but it works." The others nodded, some reluctantly. The Americans, they realized, had not designed the Sherman to outgun German tanks. They had designed it to outlast them. As the weeks went on, the tests grew harsher. The Sherman was driven through mud pits, over embankments, and across gravel until its paint was flaked away by stones. The Germans logged every kilometer. By the time the odometer passed 600, the engine still turned over as if it were new. For comparison, the early Tigers tested at the same facility often required major mechanical attention after just 200 kilometers. To German technicians used to constant adjustments, this was a kind of mechanical insult. How could something built so quickly by workers in Detroit instead of engineers in Stuttgart be so dependable? When they studied its construction, they began to understand. The Sherman was a product of industrial philosophy, not mechanical perfectionism. Where the Germans machined each component to high precision, the Americans designed around mass production tolerance, accepting small imperfections in exchange for interchangeability. Any Sherman engine could fit into any Sherman hull. Spare parts were interchangeable between factories. Everything was designed for the mechanic, not for the engineer. It was a machine meant to be maintained in war, not admired in peace. Soon, the captured M4 was joined by others. Some came from Sicily, others from the Italian front. Different models, some with cast hulls, some with welded plates, others with diesel engines. Each bore a slightly different design, yet each behaved predictably. The Germans assigned them all the same catalog number, 748A. Some were repainted in gray and used for training. Others were cannibalized for components. But a few were tested again and again, accumulating hours that no Tiger could ever hope to match. What truly fascinated the engineers was not just the tank's mechanical endurance, but its philosophy. The Americans had balanced mobility, protection, and firepower in a way that prioritized logistical flow. The Sherman could cross long distances, fight, and retreat without overstraining its drivetrain. Its armor, though not the thickest, was sloped efficiently. Its 75mm gun, while no match for the long 88, was accurate, stabilized, and backed by plentiful ammunition. Most strikingly, the crew ergonomics, spacious turret, logical controls, clear periscopes, made it a tank that could be fought effectively by ordinary men after minimal training. One officer at Kummersdorf reportedly remarked that the Americans build tanks the way we build trucks. It was meant as criticism, but beneath it lay recognition. The Sherman was not a dueling weapon, it was a system component, a cog in an industrialized army. By late 1943, reports from the front confirmed what the test ranges had shown. Shermans were appearing in vast numbers across Europe and the Mediterranean. German tank units that destroyed 1 or 2 would soon face 10 more. The battlefield itself seemed to replenish the Allies. To the German engineers who had spent their lives perfecting complexity, the realization was unsettling. Simplicity had become strategy. At Berka, another testing center, the evaluations continued. There, a mechanical officer stripped an M4A2 diesel model apart down to its hull. He noted the electric starter, the self-sealing fuel lines, the easily accessible filters, and the robust transmission. When he reassembled it, the tank started immediately. He wrote in his log that maintenance is facilitated to a degree that borders on absurd. Absurdity or not, it worked. And the engineers began to ask themselves a painful question. What if Germany had built its tanks this way? What if, instead of chasing the perfect gun or the most intricate armor slope, they had focused on a design that soldiers could sustain in the field? In the months that followed, a quiet shift occurred within the technical divisions of the Wehrmacht. Notes circulated advising greater attention to field maintenance, simplified components, and modular parts. But the war was already consuming Germany's capacity. The Tiger and Panther would continue to roll out, brilliant machines on paper, nightmares to maintain in mud and snow. The Sherman, meanwhile, would become a mechanical heartbeat for an entire army, humming from Normandy to the Rhine. By 1944, the captured Shermans at Kummersdorf were old friends to the engineers. Their olive paint had faded to gray dust, their engines still alive. Some were used as recovery vehicles, pulling other tanks from the test pits. The irony was not lost on anyone. The German engineers' own prototypes often needed to be hauled by the very American machines they had sought to mock. Then came the invasion of France. German field reports began to mirror what the Kummersdorf tests had foretold. Wherever the Allies advanced, their Shermans were always running. Panthers broke down in retreat, Tigers burned clutches in tight turns, but the M4s kept rolling. A tank that could not reach the battlefield, no matter how deadly its gun, was useless. And a tank that was always there, even if individually weaker, was unstoppable in aggregate. It was then that German engineers stopped laughing. They began to respect the very thing they had once despised, the art of compromise. The Sherman was not the best in any single category, but it was good enough in every category. And, more importantly, it could be built by the tens of thousands. The Americans had discovered the formula for wartime supremacy, quantity with quality, where it mattered most, in reliability. When the war finally ended, Allied investigators who scoured the ruins of Kummersdorf found logs detailing every test. The Shermans were still there, parked among wrecked prototypes, their hulls scarred but intact. In the margins of one engineer's notebook, faded and written in a tidy German script, was a final remark: Ein Panzer, der immer läuft, ist ein Sieg für sich selbst. A tank that always runs is a victory in itself. In the years that followed, as post-war engineers rebuilt Germany, that lesson became gospel. The new industrial generation, designing machines for peace rather than conquest, looked back at those wartime notes not with bitterness but admiration. The Sherman had taught them that reliability is not the absence of failure, it is the ability to endure it. Across the Atlantic, in factories long silent since the war's end, men and women who had once built Shermans returned to making cars, trucks, and tractors. Many never knew that somewhere in Germany their handiwork had humbled the very engineers they had once feared. Yet their design philosophy, practical, human-centered, and reproducible, had already won the greatest victory of all, proving that in war, as in life, perfection is less powerful than persistence. And so, the legend of the uncaptured Sherman at Kummersdorf endures not as a story of one tank, but of an idea, the moment when those who worshipped complexity discovered the unstoppable force of simplicity. The engineers who had once believed that German precision could conquer the world left that test ground changed. They had seen the future, built not in steel or rivets, but in reliability,